Hello everyone. In this video, we will learn how to find integral of products of sine and cosine when they have different angles. Okay, let's see these ones through some examples. The first example is sine of 3x times cosine of 2x. Well, the first idea that may come to mind is that let's do substitution. For example, we can set u to be 3x, so the first one will turn to sine of u. The second one, however, 2x, you can write it as 2/3 of 3x. Since 3x is u, so that will be 2/3 of u. So the second one still will be something else. If you fix the second one as u, the first one won't be u. It will be a multiple, non-one multiple of a u. So substitution definitely won't work in this case. Substitution works when all the angles are the same thing, okay? Very nice. So what should I do then? Well, here there is a formula that if you didn't know so far, you have to learn from this point. The formula is saying that if you have sine of an angle times cosine of another angle, this formula sometimes is called product formula. But specifically for this course, I will use the version which says ax here, bx here. So this is equal to sum of two sines. Sine of the difference of two angles, here will be a minus bx, and then plus sine of a plus bx. That is the formula that you can get from the sum formula for sine. And well, what does that give us here in this specific case? It means that you can write sine of 3x times cosine of 2x dx as sum of sine. Here a is 3, b is 2, so 3 minus 2 is 1x plus let me put half outside so I can factor up both halves and put outside of the integral. And sine of a plus b, so this will be sine of 5x dx. And when you look at this integral, you say that, oh, what happened? This is still, you're having two sines with different angles. Well, the main difference is that this is sums of two sines, and I can use linearity of integral and turn this into two different integrals. Yes. Now I can use substitution, or in general, you can say that, okay, integral of sine of mx is equal to -1 over m cosine of mx. And m is non-zero, while here we are using substitution u equal to mx. So you use one substitution for the first one and then for the second one, and the result will be -half of cosine x and -half of 1/5 of cosine 5x plus c. So that is -half of cosine x minus 1/10 of cosine 5x plus c. Very nice, and that is what we need. Okay, there are two more versions of those formula that you need to know, so let me list them here. So I'll write them product formulas, and that is inside box. We already saw one sine, one cosine. This is half of sine a minus bx plus half of sine A plus B times x. Then there are two more. When you have two cosines, if you have two cosines, then this will be half of cosine of A minus bx plus half of cosine of A plus bx. And if you have two sines multiplied, oh, this must be b, sorry, yes, and bx here, then you have still the same thing, cosine of A minus bx and half of cosine of A plus bx, but in the middle you have the negative sign. So these three formulas are what you need to know to deal with sine and cosine multiply with different angles. Okay, let's see another example, or maybe two more examples. Here I have integral of cosine x cosine 5x. That will give me integral. You see, there are halves. I can always put that each half outside, and then you get cosine of A here is 1, B here is 5. So A minus B is negative 4x. And when there are both of them are cosine, the middle it is plus. You can see up there, plus cosine of A plus B, 6x. And then we separate each one to its own integral so that we can apply substitution or apply whatever the rule we have there. And this will give me, well, integral of cosine mx is 1 over, so maybe that was to write it down here, integral of cosine mx dx is 1 over m sine mx, and when the m is not equal to 0. And again, that's result of substitution. I won't do those steps here, so I will get 1 over negative 4, there's a 2 outside, so negative 8 sine of negative 4x, plus that will be 1 over 2 times 1 over 6, 1 over 12 sine of 6x plus c. Well, there's one small thing you can do also here. There is this negative sign. Sine is an odd function, meaning that sine of negative angle is equal to minus sine of an angle. So that means that we have here 1 over 8 sine of 4x plus 1 over 12 sine of 6x plus c. Very nice. The key point is use the product formulas. That's it. Let's do one more down here. The area of the region under the graph of the function. So this function, I don't know what is exactly it's for, but what I can say is that from 0 to pi over 3, this guy is positive, this guy is positive. So whatever shape it has, by the way, it starts from 0. I don't know how this goes, but it is going to be positive. So f is positive on the interval 0 to pi over 3. So when I draw that way, I didn't mean that that's crazy like that, but it can be any shape. The important point for me here is that it's going to be positive function. And area of the region under the graph is going to be equal to integral a to b f of x dx. In this case, this is integral of 0 to pi over 3 sine x sine of 2x dx. This is product of two sines. They have different angles, so we have to use one of these product of sine formulas. So that will be cosine A minus B. A here is 1, B here is 2. So A minus B is minus x minus half. Well, I already put half outside. So minus cosine of A plus bx. So that is 3x dx. Okay. So now I can do the integration by the formulas I had up above. So integral of cosine of minus x is negative 1 over negative 1 over negative 1 sine of negative x, and the minus cosine of 3x, the integral is 1 over 3 sine of 3x. Okay, so this is antiderivative, but we have to go from 0 to pi over 3. So using fundamental theorem of calculus, I already used that. So I have, okay, so let me simplify this before I do. So cosine is odd, so that negative comes out. I will get rid of that extra negative sign there. There is 1/2, you multiply inside. This is 1 over 6 sine of 3x. You go from 0 to pi over 3. And then, well, just plug in sine of pi over 3 minus 1 over 6 sine of 3 times pi over 3 minus, plug in 0, okay. So sine of 0 is 0, 0, and this will give me sine of pi. Sine of pi is also 0, so what I will get is only the first piece. Half of sine of pi over 3, or 60 degree, is root 3 over 2, which gives me root 3 over 4. And the area that we were looking for has that value, root 3 over 4. Okay? Just very simple. You use one of the product formulas, turn product of sine and cosine, or two sines or two cosine with different angles, into one angle, into sums of two angles. Use the linearity, separate them, and then you can deal with each one of these guys separately.